Thank you everybody for joining today for today's webcast on bringing advanced analytics to the business. My name is Amanda Tesco. I am a principal BI and analytics consultant with Thorogood and also the chairman of our US company. I've listed my contact information on the screen here, so if you guys have any questions at the end of this, feel free to reach out. Just to give you a little bit of background about Thorogood, so we are a BI and analytics specialist consulting firm. We are a global company with offices in London, New York, Philadelphia, Singapore, Sao Paulo, and Bangalore, and we help our customers with a range of different strategies, solutions, and services, such as things like strategies and roadmaps, full-on implementation of systems, as well as training and adoption, and maintenance and support. We do work across a number of different sectors with a particular focus in consumer goods, pharma and life sciences, retail banking and capital markets, and insurance. And we work with a number of different technologies. So I've listed some of the technologies that we work with here. We focus quite a bit on the enterprise adoption of these technologies and how they work together. So why are we here today? Well, whether it is being attributed to the design of new drugs, saving the elephants, landing you in jail, it seems like everybody and the Pope are talking about artificial intelligence and advanced analytics. And for some people, that might be a real source of excitement, but for others, it might cause them a little bit of trepidation. And so today I wanted to really address what are some of the common challenges that our customers are having when they're trying to get the business to adopt advanced analytics projects. And then I also wanted to explore some of the approaches that you can take to ensure that those analytic initiatives are really providing business value. We're going to talk about 5 main areas today, and these will make a bit more sense as we get into them. But we're going to talk about demystifying analytics for everybody, really setting the context for people in your organization, considering a spectrum of analytic offerings so that you're not just jumping from where you're at off the deep end, really knowing what happens post your experimentation phase, and being able to design strong, well-rounded teams. So let's start off by talking a little bit about how we can demystify analytics for everybody. And what do we mean by that? Well, I think that's something we've recognized in talking to customers is that people have very different understanding and definitions of what some of the different terminologies mean when we talk about advanced analytics. And so I think an easy way to start is to really make sure that everybody does kind of understand the basics. So I like to start by just talking about some of the kind of key definitions. And for this, I will just defer to Merriam-Webster, though I think there are kind of flavors of these areas that are getting a bit kind of convoluted and people are using them a bit interchangeably. So what about artificial intelligence? That's a pretty common one that everybody's talking about. What does that actually mean? Well, according to the dictionary, artificial intelligence is really just a branch of computer science that deals with the simulation of intelligent behavior in computers. So it's fairly simplistic, right? And I think it can be interpreted pretty widely as well. So, what exactly counts as artificial intelligence is something that we've seen kind of businesses fret about quite a bit. Or what about another term that everybody is using, machine learning? How is that the same or different than artificial intelligence? According to the definition we have here, I think a big aspect of machine learning is really the ability to incorporate new data into your model or algorithms and allow that to kind of teach itself. So there's something about this iterative nature of machine learning, of being able to consistently feed in more information to refine the learnings or to find new learnings. And then some of you might have been hearing a term, or familiar with an older kind of school term called data mining. How does that kind of fit into the puzzle? Well, data mining is fairly similar to machine learning, except that it doesn't focus quite as much on that self-learning nature. Data mining is really about the practice of searching through large amounts of data using a computer to try to find useful patterns or trends. And so, though these terms all sound somewhat similar, there are different nuances in them, and they can all be used collectively as well. So you might use data mining algorithms within a machine learning program so that you can consistently get better at understanding those patterns or trends that you're finding. And you might use forms of artificial intelligence to be able to make some of those decisions in real time. As you're working with the business on understanding what we're talking about, I think it's key to make sure that they do have just this foundation and an understanding in the words that we are using. And so you might think, well, geez, what about all these? There are so many things out there that, if you're reading about that your IT department might be talking about or your data science team data scientists might be talking about things like natural language processing, digital twins, sentiment analysis. There's quite a bit out there that can lead people to feel a bit overwhelmed. And so I think something that's really good is to make sure that you're thinking about how you can inform the business and how you can kind of distill down some of these larger concepts into things that will be meaningful in business terms. Something that I found particularly useful when we've started thinking more and more about advanced analytics is how do you kind of group the different models that exist within analytics in a way that it seems more consumable? And so I like using these set of 9 boxes, and these came from a book called Data Science for Business that I think is actually a really good approach for being able to explain some of these data science concepts in business terms. And in that book, they really boil down all of the different types of models you can do into 9 different types. Things like classification, regression, similarity matching. And I'm actually thinking as I'm looking at this that it might be an interesting webcast. So maybe I'll do a follow-up session on some business examples within each of these groupings. But if you can start to distill this information into something that becomes consumable to the business, where you can explain how regression can be used to answer specific business problems, or where you might use classification or clustering, the more we can demystify some of these approaches, the easier it will be to speak the same language as some of the business users who are going to really want to engage in these sorts of initiatives and also adopt them at the end of the day. So now that we've talked a little bit about the job that needs to be done to kind of demystify analytics, what about setting the context for the business? So why are these engagements so important? And, why are we doing analytics projects? Not just to put a check in the box on many C-suite's kind of objectives for the year, but to really drive real business value. So I think it's difficult to set the context without thinking about why we're talking about it now. And we can't talk about why it's happening now without mentioning digital transformation. So what is digital transformation? Well, digital transformation is the use of new digital capabilities to reimagine business processes. And what we're seeing is companies of all different types of sizes and industries are really having to figure out how their existing business models adapt in light of all of these new offerings. I always like to use Domino's as an example here because if you think about a pizza delivery service, as a company that was fairly simplistic before. So the model would be to source ingredients, create different recipes, go through the process of creating the pizza pies, delivering the pizza pies. None of that was very digital. If you think about Domino's in the last few years, their whole model has really changed. So thinking about something like one of my favorite, the ability to order a pizza by tweeting an emoji of a slice of pizza, which sounds a bit ludicrous, I guess perhaps less ludicrous in today's environment where we're all probably ordering food a bit more than usual. But Domino's now has to think about all of these different digital touch points with its customers, how it conveys to its customers in real time the status of the deliveries, how their pizza is being prepared. And so as you start to think about how all types of businesses have to adapt and evolve in light of these new digital technologies, it starts to cause you to recognize that there's a real pressure to be able to compete. That if you're a pizza delivery service who isn't offering some of these things, that it's difficult to stay relevant. And I think what we've seen is a lot of pressure, particularly at the C-suite level, to be able to demonstrate that the organization is moving in a way that embraces digital technologies so that it can be leaner, it can compete better with different players in the industry, and that it can really innovate faster as well. So why is this happening right now? Well, there are a couple of things that are really driving this. The first is that there's just more data that exists to be collected. So if we think about things like the Internet of Things, so we think about our smartwatches or our devices, they've now become data capturing and transmitting devices. We have more information about the different touch points that people have with all sorts of different websites or applications. There's more and more data out there. Also, in terms of digital operations, if we think about sensors that are being used now on things like shipping containers, for example, that are really just providing a constant stream of information on things like the weather or the weight, it's really gotten to a point that there are so many different sources of data that can be tapped into, and everything is becoming kind of digitized and recordable. And now that all of that data exists, it's only meaningful if you can actually store it and process it. And what we've seen in terms of cloud computing and cloud hosting and open source technologies is that it's given us an opportunity to be able to store and process that data cheaper and easier than ever before. That means that we can capture things that we weren't interested in capturing before. We don't have to be particularly specific about what we do keep and what we don't. It's become a lot easier to do more experimental or exploratory things. And then the third part of this is that as the technology has really moved quickly, what we've started to see is many organizations adopting new methodologies, such as things like Agile or DevOps, continuous integration, different approaches that really allow the humans to be able to keep pace with some of these different changes. And so when we think about all of these things collectively, we start to see why all industries really are moving in this sort of direction. And it starts to really hit home the value of advanced analytics. So as you have more data, as more data can be processed and stored, if you have methods in place to be able to operationalize that data much more quickly and in a better fashion, what that allows is for you to get some really advanced insights into the information that you might not have been able to capture before. So it might give more rich history or greater breadth of the dimensions that are stored so that you can get a richer and more illuminating understanding on the other side. So as we start to talk to the business about the value of advanced analytics, I think it's important to set the context of the environment that we're all operating in today, which is that as companies rush towards making the most of these new data sources and the processing of this data, companies that aren't doing it are at risk of becoming obsolete or falling behind the competition. And so I think it's important to keep people locked onto what the business value can be in some of these initiatives, and also what the challenge or risk is if you don't capitalize on it as quickly as one of your competitors are. So now that we've talked a little bit about the context, I think the next thing to really consider is analytics as a spectrum. And so what do I mean by that? Well, when we think about advanced analytics, we talked about some of those definitions and the different words people are using, and it can mean a lot of different things. But if we think about it, analytics can be everything from basic aggregations through to your most advanced analytical models. So I've created just a kind of continuum on the screen here of analytics. If we think about the left-hand side over here as just our transactional data. So every time a data point is recorded, you have some information there. And then everything on this left-hand side is very kind of transparent and easy to interpret. You know what that data point means, and it's pretty foundational. Everything else can kind of be built upon it. And then as we start to move to the right, we start to do slightly more advanced things to that information, and that gives us more kind of insight and understanding. So as we start to aggregate it, doing things like sums or counts, we take mins and maxes, we start to get a richer picture of things. So looking at our sales summed up by different products, for example, or by different geographies, obviously tells us a lot more than if we're just kind of browsing that transactional level data on our own. And these sorts of aggregations are still very easy for the business to understand. But then as we start to move towards the right and we start to bring in more advanced analytical concepts, what we start to see is that it does get a little bit more opaque and a bit harder to interpret. So if we move kind of towards the middle here and we start to think about things like descriptive statistics or statistical inference, and what we mean by that is taking the data and looking at things like the mean of the data or standard deviation to understand the volatility in the data. We might look at how far a data point lies from the mean, how many standard deviations from the mean to get a sense of where outliers exist. We might look at histograms to see the distribution or different intervals in the data. As we start to add this level of information on it, what happens is it does start to give more illuminations and more interesting information in the data that might not be evident just from kind of sums and counts, but it does start to get a little bit harder for the business to understand. So it's a little bit more of an abstraction. And then as we start to move towards analytical models, if we think about something like basic linear regression, that might be something that can be explained to the business a bit more. You can, draw a line through data points, and that regression line will effectively help you forecast or see how far a point resides from the line. Those are things that start to become more abstract, but still are fairly easy to explain to the business where this information came from, how a coefficient in your regression algorithm might kind of impact what you're seeing on a forecast or on the other side. But then as you start to move towards the right, towards things like clustering, where you've effectively kind of grouped data points together, but you can't exactly explain to the business in layman's terms why that cluster is so similar. it starts to get a little bit more opaque, but a little bit more illuminating, because those sorts of clusters wouldn't necessarily be evident in the information without applying some sort of analytical models. And then on the far right here, I used just an example of kind of artificial neural networks. So really kind of being able to almost recreate the patterns of the human brain. Our ability to explain to the business what's happening behind the scenes in those types of models is near impossible. It's going to be very opaque to the business what's actually happening, but it's extremely illuminating. And so I think if you think of analytics on this scale, my thought would be that as you move towards the right, it will get harder for the business to understand. And something that I think we've seen is that some of our customers are going a little too far to the right. So if you are just creating the most valuable analytical model that you can create, but it doesn't quite make sense to the business, how it's calculated, why it's working that way, the chances of adopting it are fairly low. So what we've kind of been helping our customers with is to think about where on this analytics continuum should you be for each individual project you're undertaking. If you can learn just as much by using descriptive statistics as you could by using a more advanced analytical model, then perhaps it might make sense to use the descriptive statistics instead of the analytical model. If an artificial neural network would give you the perfect answer, but you could get something that is, a little bit more transparent but sacrifice a little bit of accuracy, then there's a lot of value in doing that. And so I think it's interesting to kind of think about this spread as we're devising these advanced analytics projects, and to really make sure from the beginning we've got an understanding from the business and the sorts of models we're going to use, how transparent it needs to be to them, and where they kind of want to fall on this spectrum. It's also possible to kind of move people up it. So perhaps you start with incorporating some descriptive statistics into your reporting. And then once people become more familiar with those kind of concepts, start to think about incorporating more basic analytical models. Those basic analytical models can then evolve as well. And I think something else that's really important to just think about throughout this is that data engineering is actually very paramount to all of this. So by data engineering, I mean the ability to kind of store, process, manage, cleanse the data that has to go into supporting these analytical models. And that happens throughout all different levels. And then data visualization as well. So you may be thinking about what your data visualization needs are to just look at the transactional data and see if there are any insights that pop out of it that might inspire new analytics initiatives. Or you might be looking at data visualization more towards the right-hand side to see, say, in that clustering algorithm, how those clusters of stores or of customers are grouped together and how they look on, say, something like a scatter plot. So being able to think about this kind of sandwich here and the three aspects that are needed to really make all of these work together, I think is extremely important. And then something I'll just mention is that what we've seen as many customers when starting to think about their advanced analytics initiatives have really run full steam ahead with the concept of doing experimentation with these analytical models. And what we mean by that is not necessarily thinking about the enterprise rollout of what a model would look like, but really digging into the information and trying to see if there's something of value there that might inspire a more robust analytics project. And that's really going to lead us to the next point, which is know what happens post-experimentation. So what we've been seeing is a number of companies have kind of run into this experimentation point, have found models that provide value and are meaningful, but then have really struggled to think about how those get operationalized. A slide that we look at quite a bit that I think is interesting, which is from Google, and then it gets shared quite a bit by Databricks as well, is that the hardest part of AI isn't AI, it's the data. If you look at all of the things that have to go into creating an operationalized system, or thinking about making some of those learnings from your advanced analytics initiatives repeatable and used throughout the business, that ML code is an important bit, but it's a very small piece of it. So creating the perfect model is all good and well, but there's so much around it that is important. And so something that we've started talking to our customers much more about is what happens when you need to move beyond experimentation. So if you think about the way experimentation works, these are typically models that are being created in sandbox environments, usually more kind of ad hoc or exploratory in nature. pretty low commitment. So the whole purpose of experimentation is to kind of get moving quickly and at a low cost. Typically, there's a hodgepodge of tools that are being used, or data is kind of being pulled together, hacked together in a somewhat quick and dirty way. And a lot of times we're seeing that a lot of these experiments might be done locally or in non-integrated environments. What that allows is for companies to move very quickly on the experimentation bit. But what it means is when you do find something that's valuable, the approach for operationalizing it, so getting it to be used at an enterprise scale in a way that is automated, integrated, reusable, scalable, understood and trusted by the business, and also consuming responsibly within the cloud so that your costs aren't out of control, that's a pretty challenging task. And the challenge in it comes that there are different tools, data, processes, and people that are really needed for operationalizing it versus experimentation. And so what we think is really important is as you start to undertake those experiments, to also be thinking about the operationalized portions of it in parallel. You don't necessarily want the operationalized aspects of it to limit what you do in your experimentation phase, but being able to kind of think of those things collectively is something that will help make that transition a lot more appropriate. And defining a framework or roadmap within your company for how these experiments go from that early stage experimentation to something that is more operationalized and roll out is extremely important. Else you'll find yourself with where you are getting business buy-in to some of these models. If you can't roll it out in a way that they can use it and the way that it can be kind of updated and maintained in a manageable way, then the adoption starts to fall off pretty significantly. And that starts to lead me to the last thing, which is that what we're seeing is that customers are finding it really difficult to design strong, well-rounded teams that are responsible for their analytics initiatives. And that's really because it does require a range of different skill sets and groups to work together that may have previously been working in more isolation. So if we think about what is needed within an organization or within a team to be able to let advanced analytics thrive, the primary thing is really a business stakeholder. You really want somebody involved in the group who is going to provide a business steer, who is going to ensure that the initiative stays locked on to the business goals, that we're getting a sense of where on that analytics spectrum that we want to be. We get a sense of how operationalized the solution will need to be at the end, how automated it will need to be. And you really want somebody from the business involved throughout so that they're bought into it, that they're kind of involved in the creation and development of this wider analytic approach. In addition to your business stakeholder, you'll probably need what we've called here as a data scientist. And you can think about this person as the person who might be responsible for that ML code bit that we looked at, somebody who might be building the analytical model that can help with the decision making. This person might need to have skills in things like Python or R, or different statistical methods. They might have some education in this, or they might just be self-taught. But you want somebody in that data scientist role who really does understand the correct application of models and how to devise them correctly, how to ensure that they are accurate, that there's some parsimony in them so that they're not more complicated than they need to be. And then thirdly, you want to think about the data engineering aspect. And in this case, we've got our data engineer thinking about things like operationalizing the enterprise data, being able to deploy it out to the business in a way that it's reusable, to be able to manage and maintain it on an ongoing basis, to really make kind of that transition from experiment to something that is usable and adopted. And though these three different areas may have different skill sets or different focuses, it's really key that there's strong overlap across them. And that section in the middle there, I think is really important to think about how you devise your hypotheses as a group there. So what are the sorts of things, the sorts of experiments you want to run? You want the data scientists feeding into things that they think might be interesting, using the different models they know are applicable or appropriate. You want the data engineer feeding in based on the types of data they know is available, or considerations for how things could be rolled out or could be done in a more enterprise manner. And you certainly want the business stakeholder in it telling what are the questions that are going to be worthy of some sort of investment. Because you can answer a question perfectly, but if it doesn't have high business value, it might not be worth the whole process. So using those three people to define the hypotheses that you want to test and to really kind of steer the group is really important. And then within them, there's so much overlap that needs to happen between the data scientist and the data engineer, the data scientist and the business stakeholder, and the data engineer and the business stakeholder. And I've got these as kind of individuals here, but these might be teams of people. But I think collaboration is really key in ensuring that everybody in the team has a foundational understanding of what the others know and then their particular kind of expertise, and that they can work together in this really strong, well-rounded manner. So those are the 5 areas that I wanted to talk about today. We talked a little bit about demystifying analytics for everybody, so just level setting on some definitions, defining what we mean by advanced analytics, bringing everybody into the fold so that people aren't feeling kind of excluded from the conversation. Then setting the context for people, letting them understand the big picture of what is happening in the world today with digital technologies and digital transformation, ensuring they recognize kind of the benefits and the risks of not being able to incorporate the use of advanced analytics in the organization. We talked about considering analytics as a spectrum, so not necessarily just jumping to the most complex model, but really thinking about that balance between interpretability and illumination and trying to figure out just how complex you actually need the model to be. And then we talked just now about knowing what happens post-experimentation, so having a plan, an infrastructure, and a framework in place that allows those experiments to actually generate real value within the business and value that can be shared within the enterprise and operationalized. And then lastly, we talked about the importance of creating strong, well-rounded teams that have representation from a business stakeholder, data scientists, and data engineers. So that will conclude today's webcast. So once again, my name is Amanda Tesco. Thank you for watching today's webcast. And if you do have any questions or want to chat any further about any of this, feel free to reach out to me at the contact information here. Thank you so much, and I hope you guys enjoy the rest of your day.